Welcome back to the ITONS Hub. Today we will see the postulates of Boolean algebra in discrete mathematics. I hope you have already seen the first video of Boolean algebra that was basics of Boolean algebra. If you have not seen that, then you should watch that first. In the basics of Boolean algebra video session, we had covered what is Boolean algebra, importance of Boolean algebra, history, and so on. I hope you had enjoyed that a lot. So, let's start today's session without wasting any time, that is postulate of Boolean algebra in discrete mathematics. There are several postulates of Boolean algebra in discrete mathematics. Imagine Boolean algebra postulates as the friendly guide in the world of discrete mathematics. They're like your trusty map, showing the easiest routes through logical mazes. With these guides, you breeze through puzzles, making the journey of solving problems a fun and straightforward adventure. So all the postulates of Boolean algebra are as follow. The first law of Boolean algebra is idempotent law. Second law is commutative law. Third law is associative law. Fourth law is distributive law. Fifth law is identity element. Sixth law is complement or negation. Seventh law is De Morgan's laws. Eighth law is absorption law. And we will see proof of some basic theorems. I hope you guys are getting my points. You have to just watch this video and just listen carefully, trust me, you will never forget a single thing about Boolean algebra. Next thing is, what is idempotent law? It is called idempotent because the result of Boolean variable remains the same, and it emphasizes that, if we are repeating the operation again and again, it doesn't change the outcome. It is an important law of Boolean algebra. In simple terms, if you and, or something with itself, you end up with the original thing or output. We can say that the idempotent law in Boolean algebra states that if you perform the AND operation or the OR operation of a variable with itself, the result is always the variable itself. It is further divided into two parts. First one is an idempotent law. And second one is or idempotent law. So, what is an idempotent law? Just imagine you have a statement, let's call it the. If you combine with itself using AND, it's like saying, is a true and a true, and then the result is just, again. So, A and A equals to A. Now, what is or idempotent law? Now, if you take a and combine it with itself using OR, it's like asking, is a true or a true? The answer is still, again. So, A, or A equals to A. Idempotent law in just few simple words. In Boolean algebra, idempotent law states that combining a quantity with itself either by logical addition or logical multiplication will result in a logical sum or product that is the equivalent of the quantity. Means A plus A equals to A. A multiply A equals to A. It is as simple as you think. So next thing is, what is commutative law? The commutative law is a fundamental rule that applies to both the and or operations in Boolean algebra. Commutative law is applicable only for addition and multiplication operations, but it is not applied to other two arithmetic operations, such as subtraction and division. It essentially states that the order in which you combine variables using these operations doesn't affect the result. Means as per commutative laws or properties, if x and y are any two integers, then the addition and multiplication of x and y result in the same answer even if we change the position of x and y. You can see it in this slide. Here, x plus y is equals to y plus x and x multiply y equals to y multiply x. For example, if 5 and 6 are the two numbers, then 5 plus 6 equals to 6 plus 5 equals to 11. 5 multiply 6 equals to 6 multiply 5 equals to 30. So, it is very simple. I hope you guys are getting my points. Now, what is an commutative law? If you have two variables, a and b, the commutative law states that a and b is equivalent to b and a. The order of combining doesn't matter. The result is the same. Mathematically, a and b equals to b and a, it is quite simple. For example, if a represents it's sunny, and b represents I am happy, then it's sunny and I am happy is the same as I am happy and it's sunny. It is as simple as that. The outcome, in both cases, is the same. Both conditions must be true for the overall statement to be true. Now, what is or commutative law? Similarly, with the or operation, the commutative law states that a or b is the same as b or a. It is important to note that the order of the variables in the or operation doesn't change the result. I hope you are getting my point. Mathematically, a or b is equals to b or a. For instance, if a represents it's sunny, and b represents I am inside, then it's sunny or I am inside is equivalent to I am inside or it's sunny. In both cases, if either condition is true, the overall statement is true. Now let's see next law. What is associative law? The associative law is like a rule for grouping things together in Boolean algebra. It tells us that, when we have more than two variables connected by the same operation, and or, it doesn't matter how we group them. Whether you're combining statements with and or, you can group them in any way, and it won't change the result. It's like saying the way you group things with and or doesn't matter, the outcome stays the same. Let's see a simple example to understand it easily. Now, x and y and z equals to x and y and z. Or we can say that, if we have three variables such as 2, 4, 6. Then we can write 2 multiply 4 multiply 6 equals to 2 multiply 4 multiply 6. This is for and operation, and now for or operation. X or y or z equals to x or y or z, 2 plus 4 plus 6 equals to 2 plus 4 plus 6. Now generally you can say, 2 method to represent associative law. First is an associative law. Second is or associative law. What is an associative law? If you have three variables like a, b, and c, the an associative law states that a and b and c is equivalent to a and b and c. You can group them any way you like. The order of combining doesn't change the result. Mathematically, a multiply b multiply c equals to a multiply b multiply c. The grouping doesn't matter, both expressions have the same truth value. What is or associative law? Similarly, in the or operation, the associative law states that a or b, or c is the same as a or b or c. You can rearrange the grouping without changing the result. Mathematically, that is a plus b, plus c equal to a plus b plus c. The grouping doesn't affect the overall truth value. Now let's see next law. What is distributive law? The distributive law in Boolean algebra is a powerful rule that describes how and or operations interact when combined. Distributive property explains that, the operation performed on numbers, available in brackets that can be distributed for each number outside the brackets. It is one of the most frequently used properties in postulates of Boolean algebra. Let a, b and c are three different values then. A, B plus C equal to AB plus AC. There are two aspects to the distributive law that are as follow. First is, and over or, distributive law. Second is, or over and, distributive law. What is and over or, distributive law? The distributive law states that A and B or C is the same as A and B, or A and C. Or A, B plus C, equals AB plus AC. In simple terms, it's like saying if you want to and a variable, with a choice between B or C, it's the same as andying with B and then oring it with and C. This law distributes the AND operation over the OR operation. What is or over and, distributive law? The distributive law also works the other way around. A or B and C is the same as A or B and A or C mathematically. A or B and C equal to A or B and A or C, in simpler terms, if you want to or a variable with the result of andying B and C, it's the same as oring with B and then andying it with or C. This law distributes the OR operation over the AND operation. Let's see next law, that is identity element. What is identity law? The identity element is like a special guest or number that, when combined with another statement using an or, doesn't change anything. It's like having a friend who, no matter what you do together, doesn't affect the situation. A or 0 equals to A. A and 1 equals to A, generally two elements in identity law. That is an identity element. And second is or identity elements. Now, an identity element. When you and any statement, A, with 1, it's like saying, is true and my special friend 1 true? The result is just, the special friend 1 doesn't alter or change the outcome or result. You can say in mathematically, A and 1 equals to A or A multiply 1 equals to 1. Now, or identity element. When you or any statement, A, with 0, it's like saying, is true or my friendly number 0 true? The result is still, the friendly number 0 doesn't change the outcome. You can say in mathematically, A or 0 equals to A or A plus 0 equals to A. Let's see next law. Complement or negation. The complement or negation of a Boolean algebra or expression is a new expression that has the opposite truth value of the original expression. The complement of a variable or term is indicated by putting a bar or a tilde over it. It is also an important law of postulates of Boolean algebra. Example. If A is a Boolean variable, then the complement of A is denoted as a bar, negation A, or simply -A. The complement of a Boolean expression is also referred to as inverse or negation. Not operation in complement or negation, the not operation, or complement, is a way of flipping the truth value of a statement. If A is true, then not A is false, and vice versa. You can say in mathematically, not A equals to a bar. In simple terms, think of it as looking at the opposite side of a coin. If one side is true, heads, the complement, tails, is false, and vice versa. It is as simple as that. In everyday language, if A is a true statement, not A is the opposite or false. Now, what is the truth table or condition? In Boolean algebra, truth table is a table showing the truth value of a statement formula, for each possible combination of truth values of component statements. A statement is a declarative sentence which has one and only one of the two possible values called truth values. What is truth table? The truth table for the complement is straightforward. If A is true, A complement, not A, is false, and if A is false, A complement is true. You can understand well. By looking at this table, if A is true then not, A will be false, and if A is false then not, A will be true. Our journey has not ended here. There is some more postulates of Boolean algebra. We will see them in next video. You are still watching this video, means you are getting these concepts very well. So if you have any confusion related to postulate of Boolean algebra, you can feel free to ask your doubt in comment box. I will solve your problem or doubt ASAP. And don't forget to like and subscribe this channel. Here you will learn hard concepts in just few simple words. You can also read these concepts on our website. Our website link is in description. Just open that link and accumulate several information from there. I hope you guys enjoyed this video very well. Thank you guys.